Hi everyone, welcome to this episode of Keipert Labs. In the last few videos we've been talking about ionic compounds in terms of ionic bonding, so thinking about how compounds can form when ions are joined together, and also starting to think about how we can write chemical formulas that represent how those compounds are put together. Okay, so in that video, we introduced this idea of the seesaw, okay, with the positive side, the negative side, recognizing that for an ionic compound, needs to be neutral overall. So all the number of positive and negative charges balance out. Okay, and so then we introduced this idea that, okay, if you had, say, alright, let's look at a sodium ion and looking at an oxide ion. Okay, and so actually let's look at an example that we haven't covered. Let's look at a calcium 2+ ion and a chloride ion. Okay, and so recognizing that we could say, alright, so let's represent our calcium 2+ ion as a blob with 2 pluses inside it, and that our chloride is a blob with a 1 minus inside it. Okay, and so currently we have 2 pluses and 1 minus, but we need to, what we're saying here is that we need to have the same numbers on each side. And so in order to have the same number, what we can do is that we can add another blob over here that takes us up to 2 negative charges, meaning that we're balanced. We've got 2 and 2. 2 pluses, 2 minuses. And so then what we can do is that we can write and say for every 1 calcium, I have 2 chlorides. And this is the formula for my compound called calcium chloride. Okay, we can also develop it by using a crossover technique, as far as saying, okay, so my 2 comes down to here, the 1 I have here goes over there, and so then I end up with CaCl2. Okay, but just as before, I want you to try and work with this approach in order to before you start plugging and chugging over here. Okay, but now what we're going to do is we're now going to start to look at it in terms of some polyatomic ions. So we're going to clean this off and give ourselves a bigger canvas to start with. Okay, so what we have is, we're down at the bottom here just kind of reminding us of what our goal is when we're doing this, that we want something that's neutral overall. So let's try and work out what would happen when we are looking at a compound formed from the sodium ion and then this substance over here, which is called the nitrate ion. Okay, so remember that we've talked about a polyatomic ion in the past. So polyatomic so is our group of atoms. Group of atoms with a charge. Okay, a 1 plus, 1 minus, 2 minus, 3 minus, whatever. Okay, but the idea is that it's behaving as a single group. Alright, so what we're going to do is we're going to follow the same process that we've done before. Okay, so I've got, with my sodium, I've got a blob that's got 1 plus inside it. With my nitrate, I've got 1 blob that's still got 1 minus inside it. Okay, and don't infer too much by the size of the blobs, I'm clearly not an art teacher. But the idea being that we still look at it with the same principle. Even though this ion is a new thing to see, that we look at how many pluses, how many minuses. Okay, looking at this at the moment, I can see I've got 1 and 1, so that means I don't need to adjust anything at the moment. Okay, so what I'm saying is that for every 1 sodium, I have 1 nitrate ion. Okay, so I write the formulas of the two things together and connect it there. Okay, I can do my same crossover technique. Okay, so the 1 coming down here, this one coming down here, and what would look like this is now just NaNO3. The one thing I want you to just quickly notice before we go to the next exercise is how I've incorporated these brackets over here to help kind of with the confusion. Okay, to help kind of clarify that I've got one lot of the things in the brackets. Okay, in chemistry, in this particular area of the topic, the brackets function just like they do in maths, where you're trying to keep certain things together, okay, and show that they're kind of being affected by the same thing. Alright, so let's now have a look at another example. Okay, so let's now say, alright, that I've got a calcium ion and then the nitrate ion. Okay, so what I have, so I've got a blob over here with 2 pluses, I've got a blob over here with 1 minus. Okay, now, so when I look at this, I have 2 pluses and I've got 1 minus. Okay, so what I need to do is that just like before, I need to try and balance them out. So what I can do is I can take this up to being 2 minuses by adding an extra blob. Now the only thing that's different here to what you've experienced before is what this blob actually involves. Okay, and so we're going to do the same process otherwise. So for every 1 calcium, I have 2 lots of the nitrate ion. But now the thing is that if I put a 2 here at the moment, then it looks like I have 1 nitrogen and 32 oxygens in this thing, which is clearly not logical and not sensible. So what I need to do is I need to show I've got 2 lots of this whole substance. And so what I do is I say, right, well, let's put brackets around that and then put the 2 around the outside to show that I've got, for every 1 calcium, I've got 2 lots of this ion. Okay, so the brackets help to minimize the confusion when I have more than one of a particular polyatomic ion. Okay, so I use the brackets. Okay, so when I have more than 1 polyatomic ion. Now I don't need them at any other time. I didn't in the previous example because I only had 1 nitrate, but here I've got more than 1 polyatomic ion, so it helps with the confusion. Okay, let's have a look at another example to kind of help firm this up for us as to why we're doing what we're doing. Okay, so let's say I'm wanting to do it with the potassium ion and then this ion, which is called sulfate. Okay, sulfate. Alright, so just as before, I've got a blob over here with a 1 plus charge. I've got a blob over here with 2 minuses. Okay, so when I tally that up, I've got 2 and I've got 2. Alright, so what I now need to do, just as before, I can then balance it up by adding an extra blob with a plus over here. Now I have 2 pluses, 2 minuses. Oh, I preempted that a little bit by writing 2's on both sides, my bad. Okay, and so then I can, with my formula, say for every 2 potassium ions, I have 1 sulfate. Okay, so I could have again done my crossover technique over here. Okay, so to show, to bring the 2 down here, the 1 down here, and then gone with K2SO4 1, but then the 1 isn't necessary, so I can take that out. And I have my formula. So this is called potassium sulfate. Okay, so the same process that we followed before. Alright, so we were balancing positive and negative charges based on, adding extra lots of one side or the other. Okay, let's look at one last example. Let's kind of swing for the fences a little bit on this one, and I'll show you what I mean. Okay, so we're going to, but the same principle applies, exactly the same kind of process. Okay, so we're going to say, all right, let's look at our aluminium ion, and then we're going to look at this ion, which is called carbonate. Okay, so carbonate, so CO3 with a 2 minus charge. Okay, so I've got a blob over here with 3 pluses. I've got a blue blob over here with 2 minuses. Okay, and so running my tally, I've got 3 pluses and 2 minuses. Okay, so if I start by evening it up by adding an extra 1 over here, then I've got 4 and 3. Okay, so all I can then do is start to add another 1 over here, which has 3 pluses. Okay, so that makes it 6. To even it up, then I can go for another 1, which gives me 3 lots of that, making 6. So I end up with, for every 2 aluminiums, I have 3 carbonate ions. Okay, so get to those practice questions. Thanks very much for watching. Bye for now.